Chapter 3, Section 1, Sensation. What is the difference between sensation and perception? A sense is a system that translates outside information into activity in the nervous system. Messages from the senses are called sensations. Perception is the process of using information and your understanding of the world so that sensations become meaningful experiences. How does the information from my eyes and ears get to my brain? Each sensory system detects a specific form of environmental energy, like sound, light, heat, and physical pressure, and encodes this energy into neural activity and relays these signals to the brain. Accessory structures modify the incoming stimulus. Transduction is the process of converting incoming energy into neural activity. Transduction takes place at receptors, specialized cells that detect certain forms of energy. Sensory receptors respond best to changes in energy. Adaptation is a decreasing responsiveness to constant stimulation over time. Sensory nerves carry information from the receptors to the brain. For all senses except smell, the information first goes to the thalamus and then to the cerebral cortex. Coding translates the physical properties of a stimulus into patterns of neural activity. The absolute threshold is the minimum detectable amount of physical energy a sensory system can detect 50% of the time. Signal detection theory is a mathematical model of how personal sensitivity and response criterion combine to determine your decision about whether a near-threshold stimulus has occurred. Sensitivity is a person's physical ability to discriminate a stimulus from its background. The response criterion is the internal rule or physiological bias used in deciding whether to report a signal. Weber's law states that the smallest detectable difference in stimulus energy is a constant fraction of the intensity of the stimulus. The sensory energies of light and sound vibrate as waves passing through space. These energies have three properties that determine what is sensed and perceived. Wavelength is the distance from one peak of the wave to the next. Wave frequency is the number of complete waves or cycles that pass a given point per unit of time, and amplitude is the height of the wave from baseline to peak. Why do some people need eyeglasses? Light is a form of energy known as electromagnetic radiation. Most electromagnetic radiation passes through space undetected by the human eye. Visible light is electromagnetic radiation with wavelengths between 400 and 750 nanometers. Light can be referred to as either light waves or light rays. Sensation of light depend on the intensity and wavelength of light waves. Light intensity refers to how much energy the light contains. It determines the brightness of light. Light wavelengths create the sensation of different colors. Accessory structures of the eye modify incoming light rays. Light waves enter the eyeball through a curved, protective, transparent membrane, the cornea. Light then passes through the pupil, an opening just behind the cornea. The iris adjusts the amount of entering light by constricting to reduce the size of the pupil or relaxing to enlarge it. The curved lens behind the pupil bends and focuses light waves onto the retina at the back of the eye. Light rays from the top of an object are focused at the bottom of the image on the retinal surface, and those from the right side of the object end up on the left side of the retinal image. The brain then rearranges this upside-down and reversed image so we see the object as it really is. In accommodation, the lens changes shape to focus images at different distances onto the retina. This ability declines with age as the lens loses flexibility. Conversion of light energy into neural activity takes place in the retina in specialized cells called photoreceptors. Rods and cones are two main types of photoreceptors that contain chemicals that are light sensitive. Dark adaptation is the increasing ability to see in the dark over time due to the buildup of light-sensitive chemicals in the rods. Rods are more sensitive to light than cones and allow you to see in dim light. There are no rods in the fovea, the center of the retina, but there are a large number in the periphery of the retina. Cones allow you to see color. Most cones are packed in the fovea. The density of the cones accounts for differences in visual acuity and the ability to see details. Cones do not work well in low light. Signals generated by the rods and cones go back to the surface of the retina, making connections with bipolar and ganglion cells. This allows the eye to begin analyzing visual information in the retina. The axons of the ganglion cells form the optic nerve, which then goes to the brain. Because there are no receptors for visual stimuli at the point where the optic nerve exits the eyeball, a blind spot is created. Seeing color. The sensation produced by a mixture of different wavelengths of light is not the same as the sensations produced by separate wavelengths. Three separate aspects of the sensation of color are hue, saturation, and brightness. They are the psychological dimensions. Hue, the essential color you see, is determined by a light's mixture-dominant wavelength. Saturation is the purity of a color. A color is more saturated or more pure if a single wavelength is more intense or contains more energy than others. Pastels are colors that have been desaturated by the addition of whiteness. Brightness refers to the intensity of the light. White is the result of adding all different colors. The trichromatic theory was proposed by Thomas Young and Hermann von Helmholtz. They proved that by mixing pure versions of blue, green, and red light in different ratios, they could produce any color. There are three types of cones, each most sensitive to a different wavelength. Short wavelength cones respond most to light in the blue range, medium wavelength cones respond most to light in the green range, and long wavelength cones respond most to light in the reddish-yellow range, although by tradition these are known as the red cones. The ratio of the three cones types activities determines the color sensation. This theory was applied to the creation of color television screens. The opponent process theory of color vision, proposed by Ewald Hering, holds that color-sensitive visual elements are organized as pairs with the pair members opposing or inhibiting each other. The three pairs are red-green, blue-yellow, and black-white. Each element signals one color or the other, but never both. This theory explains color after images. People with color blindness discriminate fewer colors because they are missing one or more of the three color-sensitive pigments in cones. Color blindness is more common in men than in women. How would my voice sound on the moon? Sound is a repetitive vibration in the pressure of a substance such as air. As the moon has almost no atmosphere or air pressure, sound cannot exist there. Vibration of an object produces the fluctuations in pressure that make sound. A wave is a repetitive change in pressure that spreads out in 3 dimensions. Physical characteristics of sound waves determine psychological dimensions of sound. Loudness, measured in decibels, is determined by sound wave amplitude or height. The minimum detectable sound for normal hearing is 0 decibels. Pitch, how low or high a tone sounds, is the frequency of complete waves that pass a point in 1 second. 1 cycle per second is 1 hertz. Humans can hear sounds ranging from about 20 hertz to 20,000 hertz. Timbre is a sound's quality. It is determined by mixtures of frequencies and amplitudes that result in complex wave patterns that are added to the lowest or fundamental frequency of a sound. The human ear converts sound energy into neural activity through a series of accessory structures and transduction mechanisms. Please look at the diagram that you created for your ear for more details on the parts of the ear. There are two basic forms of deafness. Conduction deafness occurs when the middle ear's bones fuse so they cannot properly amplify vibrations. Treatment includes hearing aids, which amplify the signals reaching the inner ear, surgery to break the bones apart, or replacing the natural bones with plastic ones. Nerve deafness results from damage to the auditory nerve or the hair cells. High-intensity sound can actually rip off the hair cells of the inner ear. Scientists are working on regenerating hair cells in human ears. In the meantime, artificial cochlear implants have been developed to stimulate the auditory nerve. Why can't I taste anything when I have a cold? A food's flavor depends on both smell and taste. Both tastes and odors prompt strong emotional responses. Humans learn aversions to odors more readily than to tastes. Variations in our nutritional state also affect our experience of taste and flavor as well as our motivation. Warm foods taste sweeter, and the aroma of warm food can create more flavor sensations. Spicy, hot foods actually stimulate pain fibers in the mouth because they contain a substance called capsaicin. Our sense of smell. The sense of smell, or olfaction, detects chemicals that are airborne. Neurons in the upper nose detect molecules that pass into its moist lining, the mucous membrane. Odor molecules bind to receptors on the dendrites of the olfactory neurons and lead to changes in the firing rates of these neurons, whose axons combine to form the olfactory nerve. Olfaction is the only sense that does not send its message through the thalamus. Olfactory axons extend directly into the brain to synapse in the olfactory bulb. The olfactory bulb's connection to the amygdala, which plays important roles in emotion and memory, may underlie the special relationship between smells and emotions or memories. Some animals release pheromones, chemicals that other animals detect and respond to behaviorally and physiologically. The role of pheromones in humans is not well understood, but odorants that cannot consciously be detected can influence mood and stimulate activity in non-olfactory areas of the brain. The sense of taste, gustation, detects chemicals in solution that come into contact with receptors inside the mouth. Gustatory receptors are in taste buds grouped together as papillae on the tongue, roof of the mouth, and throat. The human taste system detects only a few basic sensations: sweet, sour, bitter, and salty. Umami, which is triggered by monosodium glutamate, or MSG, and certain other proteins, and astringent, which is produced by tannins like those found in tea, are the two newest taste sensations. Which is the largest organ in my body? The somatic senses are located throughout the body rather than in a localized specific organ. 4 senses of the skin are pressure, warmth, cold, and pain. Pain tells you about the impact of the world on your body and has a distinctly negative emotional component that interrupts whatever you're doing. The gate control theory says that there is a gate in the spinal cord that allows either pain signals to reach the brain or stops them. The brain can close the gate with descending signals into the spinal cord. The result is analgesia, a reduction in pain sensation following a normally painful stimulus. Drugs that dull pain are called analgesics. Natural opiates, called endorphins, act as neurotransmitters and can block several levels of pain pathways into and within the brain. Sensing body position. Proprioception refers to sensory information about one's body, as opposed to sensory information about the external environment. Kinesthesia is a sensory information about where your body parts are relative to each other. And vestibular sense is often thought as our sense of balance. And that is it for Section 1, Sensation.